Hello, students. So, this video is related to the concepts of finding the missing angle from the right angle triangle, finding the missing sides, angle of elevation and depression, what we have been doing so far. So, before I go, what I suggest you to always keep the notes of your formula sheet in front of you. So, what is that? We know that if we have an opposite by hypotenuse, we say that's a sine theta. If we have an adjacent by hypotenuse, then we call it cos theta. And if we have something like opposite by adjacent, then we call it tan theta. Okay. So keeping in this mind, let's work with few of the problems. So let's say in number 2, in this right angle triangle, always fix up your what is where with respect to the angle given. So this angle is given. So that's our oppo that has to be the adjacent, and opposite to 90 degree always hypotenuse. Okay. So what do? We need to know what is this x, and we are given with this adjacent. So the relationship is between opposite by adjacent. So what do I should write? If you look, opposite by adjacent is your tan. Okay, so we write that's equals to tan, and the value of the theta, this angle is here, is given at, let me refresh that one, so it's 62. Okay, so this is 62. All right, so now let's plug in the values, or in other words substitute. What is your opposite? That's your x. Okay, that's our unknown, and your adjacent is this 25, and that's 10 62. Okay, so it's just a simple algebra right now. I need this guy, so I multiply, or you can say I can transfer with 25. This guy cancels out. So what happens? X equals 25 multiplied with 10 62. Okay, so that's it. You can put it in parentheses or not. Now it's a job of the calculator. Go back to the, so what is that? 25 10 62. So I say 25 multiplied with 10 62. Okay, remember that your calculator should be in degree form. So 47.01. Okay, so once we have 47.01, since it's the nearest 10th, so what do you say? Forget about this guy, since this is not 5 or more than 5, so we say 47.0. Okay, that's it. And next, let me do the inverse of this. Okay, I hope I can keep these things intact. Okay, this should be hypotenuse. So here I'll have to find out the angle. So this is my oppo, this is my adjacent, this is my hypotenuse. So what are the data given? Adjacent by hypotenuse. So adjacent by hypotenuse, and I'll have to, what is the relationship? Adjacent by hypotenuse is this, so cosine theta. So cosine theta is our this angle x. Okay, so we say that's x. Okay, so we say our adjacent is given as 14. So 14 over this hypotenuse is 15. So we say cosine x. Okay, so as I have told you, since this is shifting over here, so we say cos inverse 14 over 15, and that's our x. So now it's a calculated job. Put it in the calculator, cos inverse 14 over 15. So come back to the calculator, 14 over cos inverse. So second or shift cos inverse 14, if I'm not wrong, over 15. Okay, so it's a 21.03. So this guy gives us the value 21.03. So since this guy is not more than 5, we say 21.0. That's it. Okay. So let me move on with few of the application problem. Okay, so basically the once missing sides can be found out, missing angles is with the inverse, and now application. You say number 10. Jada is standing 10 feet from the base of a tree. So let the tree be like this, okay? So from the base of the tree, Jada is standing 10 feet. So let Jada from the base. This is 10 feet, okay? Now, and it spots a nest sitting on the branch. So somewhere on the tree, the branch is there. Let's say this is here, okay? The angle of elevation from the ground. So go back to the angle of elevation formula. Okay, what is that? That is like, let me read that one. When looking up to an object, the angle of elevation is formed by an observer's line of sight. Observer's here line of sight for eyesight is this, and the horizontal line. So that's the horizontal line. Yep. So this is the angle of elevation. That's what it's saying. Okay. So here, what will happen? I think that was we were working. No, that I worked in the class. Okay, so here. So this line and this horizontal line. Okay. So this, the right angle triangle. Okay. And this angle is given between this is this, that's as 55. Okay, so comparing to these are opposite, these are hypotenuse. No, this is our adjacent and these are hypotenuse. I need to find the height of the nest. Okay, so this, okay, so this is the opposite, and I have the data for adjacent. So adjacent should be 10. Okay, so 10, 55. So let me plug in the values. Opposite is x, my unknown. Adjacent is 10. That is 10, 55. Okay. So just x equals 10, 10, 55. Okay. So now it's a calculated job. So 10 multiplied with 10, 55. So I say 10 multiplied with 10, 55. So whatever the value is, 14.28. So this guy is, x is 14.28, okay? So one decimal place, 14, since it's more than 5, I add 1. So 14.3 is the height of the nest. So x is 14.3. That's it. Let me work with the depression problem. So what it tells, something like a surfer is riding a 7-foot wave. So this is something like a wavy thing. So he's riding a 7-foot wave. Okay. The angle of depression from the surfer to the shoreline is 10 degrees. Okay. So it's something like the surfer is here. Okay. So the line is, shoreline is here. So this is it. That's the line and the eyesight. Okay. So what does it tell? The depression theory that tells us, definition of depression, that tells us that when looking down to an object, an angle of depression is formed by the observer line of sight and the horizontal line. Okay. So this is, he's coming to the shore. Oh, okay. So what is happening is riding a 7-foot wave. Okay, the angle of depression from the surfer to the shoreline is this. Okay, so this to the ground, he's here, so he's looking down, or you can say he's looking down. Okay, let me work with this since I've shown you this way. So with the shoreline, this is the thing, and this is the angle, which is given as we don't know. Yeah, it's 10. Okay. So now I can do it anyway, okay? Writing 7 feet wave, okay? And that should be the height of the wave, okay? So over here, that's 7. And once you draw this is the angle which is equal to this, or you can work like this, okay? This is horizontal line, so they will be parallel, this, any of the thing. I'll prefer to take this triangle, okay? So let me see this, okay? So the comparison angle, this is my opposite, this is my adjacent, this is my hypotenuse. So what they want the distance from the surfer to the shoreline, okay? So this should be giving me this distance. The sharper is here, the shoreline is, so this distance I should find. So adjacent by opposite by adjacent, okay? Opposite is 7, my adjacent is, I don't know, x, okay? So that should be giving me that opposite by adjacent is 10, 10, 10, okay? So I need this, I bring this guy down, 7, 10, 10 is my x, okay? So it's now a calculated job, okay? So that's like 7 over 10, 10. So that's 7, okay, let me go, 7 over 10, 10. That's it, 39.69, okay? So that is 39.69 means we add 1 over here, so 39.7, all right? Okay, let me try with another one so that you get fully clear of the concept. Let me put out with 14. The cell phone tower is anchored by 2 cables on, that's what I did in the class, huh? No, anyway, let's go into it again. A cell phone tower is anchored by 2 cables on each side of its support. So let this be the tower, okay? Let me draw it like a tower, okay? So it's something like this, huh? Okay? The cable is anchored by 2 cables on each side of the support. So it's like cables are coming like a support, okay? The cables stretch from the top of the tower to the ground. That's what I've shown you. This is the ground, this is the top. With each being equidistant from the base of the equidistant means equal distance, okay? Equidistance, equal distance. So from the ground, let's say if it is the ground of the tower, now I consider it as a line, okay? So this distance and this distance are equidistant, so they are the same, okay? That means calculating one will be able, I will be able to find out the other. Let's see what they want. The base of the tower. The angle depression from the top of the tower to the point which the cable reaches the ground is 23 degrees. So let me consider any of them, okay? So this angle is 23 because this is the ground, okay? So if I consider this right angle triangle, so this one is alternate angle, so they become equal, okay? You remember this alternate, okay? This guy is equal to this guy, okay? So if I work over here, I have what I have, data. The tower is 140 feet tall, okay? So this is 140, okay? So considering this angle, fix up, this is my oppo, my adjacent, okay? This is my hypotenuse. So I'm giving you the oppo by adjacent, okay? So 140 over, okay, oppo by adjacent, okay? So what should I write? Oppo by adjacent is my 10, 23 degree, okay? So my adjacent is x. I need to find out that. So I say 140 divided by, this guy comes over here, so 1023. Okay, that's my x. Okay, so now it's a calculated job. 140 divided by 1023. So 140 divided by 1023. Okay, so add that 329.8. So it is 329.8. 329.8. Okay, this x. Now my job is not done. Remember that they said, they asked us to find the ground distance from the cable. So what I done, this was the cable tower height. The cables were like hanging from this. Okay, hanging from this equidistance. So he said if it is x, this is x. So this one we have found as 329.8. So this is 329.8. This is also 329.8. You can add them up or you multiply it. 329.8 multiplied with 2. Put it in calculator. 329.8 into 2. 329.8 into 2. Let's say this value, I think if we multiply, answer multiply 2 also works. So 659.60. 659.60. So we say this guy is 2x is 659.28. Okay, is it 28? Let me check up. 63, sorry. I forget things very quickly. 63. So that's 63. Okay. So I keep 6 over here. 659.3. That's it. You should be good. Okay. Good luck. Thank you.